Hello everyone, welcome back to our channel. Today we are going to do a very interesting question, single element in sorted array. Uh, so make sure to watch the whole video. First of all, we'll try to understand the question, then we'll move to the brute force approach, and then finally we'll optimize it. So it's very important you understand the whole journey so you can solve similar questions when you see them. So let's understand the question first. Single element in a sorted array. You are given a sorted array consisting of only integers where every element appears exactly twice except for one element which appears exactly once. Return the single element that appears only once. Okay. Your solution must run in O of log n time and O of one space. Let's have a look at what this question actually means with help of one example. Let's take this example 1 1 2 3 3 4 4 8 8. 1 1 2 3 3 4 4 8 8. Okay. Now the best way to solve it, the easiest way that comes to your mind, not the best way, is linear search. Right? We can simply go ahead and search the array that is appearing only once. So in this particular test case, the answer is 2. That is appearing only once. All other numbers are appearing multiple times. And the best part about it is that the array is already sorted. So the same numbers are going to come together. So how do we run a linear search on this? It's very simple. We start from the 0th index. Okay. We check whether the current number and the next number are same or not. They are same in this case. So what do? We move two spaces ahead. Now, is the current number and the next number same? No, they are not. So this is your answer. That's it. This is how we search for it using the linear search approach. Let me write a small pseudo code for this. But there is one corner test case that I would like to discuss with you before writing the pseudo code so that we can cover that in our pseudo code as well. The corner test case is that when the number is at the very end, when the single number is at the end, it's 1, 1, 2, 2, 3. So we start from here, check the current number and the next number, they are same. We move two spaces ahead. The current number and the next number again, they are same. We move two spaces ahead. Now when we check the current number and the next number, we go out of bounds. See, that is the problem that we have to solve. So what do? We only go till n minus 2, not till n minus 1, not till the last index. You only go till second last index. And even if we are not able to find the answer till then, we return the last number of the array as the answer. That's it. That's the quick fix for this particular test case. Let's write the pseudo code now. So we loop, or let me write it in form of a for loop so that it is easier to understand. So for int I equal to 0, I less than n minus 1, and I plus plus. Instead of I plus plus, we want to skip two spaces every time. So it will become I equal to I plus 2. Okay, this is the change in condition that we have. Once we are inside the for loop, what do we have to do? It's quite simple from here. If the current number and the next number are not same, we have our answer. If the current number a of I is not equal to a of I plus 1, right? If the consecutive numbers are not same, we have our answer. We can simply return a of I as the answer. When this loop is over and we still haven't found our answer, what do? Once we come out of this loop and we still haven't found our answer, we already discussed this. The last number is the answer. So we can simply return a of n minus 1. And that is pretty much it. This is the linear search approach. It will take O of n time complexity, but this is very high. Why? Because we are doing searching on a sorted array. So that should give you a hint that binary search might be a possible solution to it. Let us have a look at how we can apply the binary search on it. Before that, let me give you a 1 minute overview of how binary search actually works. There are some numbers. The array is sorted. And let me just take a sorted array. There is an end point, there is a start point, and we calculate the mid. We check whether the target is greater than this or smaller than this or equal to this. If it is equal to this, we have found the target. If it is less than this, we eliminate the right side. And if it is more than this, we eliminate the left side. How do we do that? All the numbers less than 8 lie on the left, while all the numbers greater than 8 lie on the right. And that is how we can easily eliminate one side of the array every single time. But this is not the case for the current question. So let's see how we can tweak binary search a little bit so that it works on the current question as well. So let's take one example, and there I'll try to explain to you what the optimal solution for this particular question is. So let's take 1 1 2 2 3 3 4 5 5 6 6. Okay. Let me write the indices as well: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, there is something I would like to highlight. This is the number that has appeared one time, right? This is the number that appears single time. Now, what you need to notice is before that, okay, listen to this very carefully. This is the main part of the solution. If we go before that on a even index, let's take this. The repeating number is on the right. Do you agree with me? If we go before the single digit and we are on a even number index, then the repeating number is on the right. The next one is the repeating number. Similarly, when we go to the right of it and we are on an even index, the repeating number is on the left before it. Right? This is the subtle difference that happens when this number has appeared. Similarly, I'll explain to you what happens with the odd indices. We have seen what happens with the even indices. If you are before this single number on an odd index, then the repeating number will be on the left. If we are on a odd index, after this single number has appeared, the repeating number will be on the right. So this is the difference that we are going to take into account to create our answer and find out whether we are standing on the left of that single number or on the right of that single number. Okay. So let me create a pseudo code so that it's easier for you to understand, and then we'll move towards the code part. So like any other binary search, we are going to start with the three variables. There's a beginning, there's an end, and then there is a mid. We will run this binary search while beginning is less than the end. Once we are inside the while loop, the first thing we do is we calculate the value of mid. The safest way to calculate the value of mid is s plus e minus s by 2. We can simply do s plus e by 2 to get the mid value, but that can go out of bounds. So it's s plus e minus s by 2. After we have done that calculation, what do we need to find out? We need to find out whether mid is on the first or the last index of the array, right? Because if we have reached either ends, that means that is our answer. Okay. So if mid is equal to 0 or mid is equal to n minus 1, either the beginning or the end, if we have reached there, then that is your answer. You can return that as the answer because it is guaranteed that the answer will be there. So you can simply return array of m in this case. Now we will check if we are on a even index. Let's say m mod 2 is equal to 0. So we are on an even index. So as we saw, if we are before the single number on an even index, the repeating number will be on the right. While if we are on the right of the single number or on an even index, the repeating number will be on the left. So we'll take advantage of this property to understand if we are on the right or on the left of this answer. So once we are inside this if, what do we have to find out? We have to find out where the repeated number is. So if a of m is equal to a of m plus 1, if the next number is equal to the current number and we are on an even index, right? So when does that happen? When we are behind the answer. If we are behind the answer, what do? We make beginning equal to mid plus 1, right? So that is what we'll do. So that the left side gets rejected. The left side gets rejected. Okay. Similarly, if the repeating number is on the right, okay, else if it is on the right, then what do we have to do? We have to reject the right side. So what do? End equal to mid minus 1. Alright, similarly, we'll do it for the odd indices. For the odd indices, we'll again check if the number is on the right. If the same number is on the right, when does that happen? Let's have a look at that and look at it very carefully. We're on an odd index, okay? I'll just erase all of this. Let's say we are over here. The same number repeats on the right. The next one is the same number. It happens after the answer. So we have to go left. So if this happens, we have to go left. How do we go left in a binary search? We make end equal to mid minus 1. And again, else condition, we have to delete the left part of the array. What do we do? Begin equal to mid plus 1. And that's it. We keep iterating this particular while loop until we get our answer. And what we'll do is we'll eventually hit this statement when our mid is standing on the answer and we return that as the answer. So this is the pseudocode. And now we will move towards coding this problem, guys. Okay, everyone. So let's code this problem in. We're going to take the variables first. Begin start from 0. End starts from nums dot size minus 1, the last index. And then we have a mid. We will run this code while s is less than equal to e. Once we are inside, the first thing we do is calculate the value of mid. Now, once we have the value of mid, we'll first of all check if mid has reached the corners or not. If mid is equal to 0 or mid is equal to nums dot size minus 1, it is at either ends, the beginning or the end, we're going to return that as the answer. So we can simply return nums of m in this case. Now we go into else if, and now we check if this current value is the answer or not. We'll check the number in front of it and check the number behind it. If both of them are not equal to the current number, we return this current number as the answer. So nums of m is not equal to nums of m plus 1, and nums of m is not equal to nums of m minus 1. So the current number is not equal to the number next to it or before it. In that case, the current number is the answer. So we return nums of m as the answer. Now we check whether we are on an even index or an odd index. So if mid mod 2 is equal to 0, that means we are on an even index. And now we'll check whether the repeating number is on the right or left. And based on that decision, we will either remove the left part of the area under consideration or array under consideration, or the right part of it. So if nums of mid or nums of m is equal to nums of m plus 1, if the current index, if the number at the current index is equal to the number at the next index, and we are on an even index, that means we will make s equal to mid plus 1. We are going to remove the left part of the array. Otherwise, we are going to remove the right part of the array and make e equal to m minus 1. After this, if the value of m mod 2 is equal to 1, which means we are on an odd index. If nums of m is equal to nums of m plus 1, in this case, what will we do? We will remove the right half of the array by making e equal to m minus 1. And otherwise, we'll remove the left half of the array by making s equal to m plus 1. And that is pretty much it. After all of this is over, we can simply return a 0 and be done with this. What will happen is, while we iterate inside this while loop, our mid value is going to get concentrated or move towards the answer. And we'll hit this condition and return the answer. There's a spelling mistake over here. For the starting pointer, we have used S throughout the code. So let's make that S. Let's try to run this now. Let's try to submit this. All right, so all our test cases got passed. Thank you so much for watching this. Whatever doubts you have, please feel free to put them in the comments. I'll be more than happy to answer any doubts that you have. Thank you so much for your time, guys. Have a wonderful day. I'll see you in the next video.